Now we are ready to solve some basic inequalities. So the way that we solve inequalities is very simple. All we got to do is just treat it as a regular equal sign. So let me give you a really quick example. So let's say we wanted to solve this following problem. X plus 3 is greater than 5. Okay, well, this is very simple. All we got to do is just pretend that this is actually an equal sign. All we got to do is just minus the 3 to the other side. Get rid of that. So x is greater than 2. Okay, so this actually is the answer. X is greater than 2. Okay, so let's say this was part A. We wanted to solve. Part B would say, write solution in interval notation. Okay, so how would you go ahead and do this? Well, what you would do is you would first draw a number line. Here is 2. 2 is not included because it's greater than, so it's not included. Everything that's greater than is going to be this way. And over on this side is infinity. The way that we would write it in interval notation is parenthesis 2 all the way to infinity. Okay, and that will be my solution. Now, what exactly does this mean? Because before we had x equals 2, we would plug it in to check our work. Well, how do we know? Well, all we got to do is just pick any value of x that is greater than 2. For example, 3. 3 is greater than 2. So when I plug 3 back into the equation, you get 3 plus 3 greater than 5. Oops, not greater than or equal to. Greater than 5. So, and then we get 6. 6 is clearly greater than 5. So I can choose any x value that is greater than 2, plug it back into the original, and that will make the statement true. Okay? That's all there is to it. Okay? So let's try another problem. So let's say we wanted to solve, and what we wanted to solve was 2x minus 7 is less than or equal to, I don't know, let's say 5. Okay, so you can go ahead and try this out if you want, or by pausing it, or you can do it with me right now. So the first thing that we're going to do, let's solve for the value of x. Let's move the 7 over. So I'm going to add the 7, add 7. So now I'm left with this 2x. 2x is less than or equal to 12. Now I'm going to divide by 2, divide by 2. X is greater than or equal to 6. So this is my solution. X is greater than or, less than or equal to 6. All right. Part B, let's say we want to write it in interval notation. Okay, what would that be? Well, first thing that we want to do is graph it. This is optional. You don't need to graph it, but I'm a very visual person, so I like drawing it. Here is 6. Since 6 is greater than, and there's a greater than, an equal sign there, you're going to go ahead and make it as 6 being included. So we're going to put a closed circle. Then everything that's less than 6, everything that's less than 6 is over here. Over here is negative infinity. Remember, negative infinity does not have a bracket. It's a parentheses. So parentheses negative infinity all the way until I get to 6. And 6 here is included, so we're going to write a bracket. Okay, that is my answer. Okay, now one thing that you have to be very careful with, and I'm going to put a warning sign. All right, warning. Okay, and the warning comes when you divide or multiply by a negative to both sides. So what happens here is that when you divide or multiply by a negative to both sides, what you have to do, you have to change the sign. So you got to flip the sign over. And this makes sense because let's say we had 2 is less than 10. Well, this is a correct statement because 2 is clearly less than 10. Now, what happens when I divide both sides by a negative? Okay, so let's say I divide it by a negative. So what I'm going to get is negative 2 is less than negative 10. This is not correct anymore because negative 2 is not less than negative 10. Negative 2 is greater than negative 10. So what happens here is that whenever you divide by this negative, some sort of negative, or even multiply it, you have to switch the sign. So this is no longer that, it has to be a greater than sign. Okay, so only when you divide or multiply by a negative to the other side. Okay, not when you add or subtract. So let's do an example of this. So let's say we had solve, okay, let's say we had negative y over 3 plus 7 is less than, I don't know, 2, I don't know, okay, something like that. So one of the things that you want to do, and notice that I changed the variable now to y because it can be any value that you want. It doesn't necessarily have to be x. So the first thing that I'm going to do, I'm going to solve it like a regular problem. I'm going to subtract by a 7. Okay, so I'm going to have negative y divided by 3 is less than 2 minus 7 is going to give me negative 5. Okay, now what I'm going to do, how do I get rid of this 3? Well, this 3 is being divided, so in order for me to get rid of this division by 3, the opposite of division is multiplication. So I'm going to multiply both sides by 3. And I'm going to write it as 3 over 1. Okay, so now the 3's are going to cancel out, and now what I'm left with is this negative y is less than negative 5 times 3 is going to give me negative 15. Okay, and now I'm almost done, but notice what's going to happen. I'm going to divide by this negative, but once I divide by this negative, I have to flip the sign. So y is now greater than positive 15. That is my answer. Okay? All right, so just be very careful with the flipping of the sign. What is it in interval notation? In interval notation, we have 15 right here. Let's say that's 15. 15 is not included, and it's everything that's greater than y. Everything that's greater is this side. Over here is infinity. So it's going to be from 15 all the way to infinity. Okay, and that is my final answer. Okay, all right, so let's try these next problems. Okay, so what I want you to do, I want you to solve them. Solve and write in interval notation. Okay, so my first problem is going to be this. N over 3 plus 4 is less than 10. And then, let me write a 2 in here. 2n over 3. And then for this one, let's say we have 1/3 x plus 1/2 is greater than or equal to, I don't know, 4. And let's make this a negative. Okay, and the reason why I'm doing problems like this is that a lot of you are still having problems with the fractions, and I want you to be very, very careful with fractions like this and how do you deal with them. So you can either pause the video and you can try them out, but I'm gonna go ahead and jump in and try to do these two problems. Okay, so first, here's the first one. The first thing that I'm gonna do is solve for n. Let's go ahead and minus the 4 first to both sides. So you get 2 over n divided by 3 is greater than 6. Notice I didn't flip the sign. I subtracted by a 4. I didn't divide or multiply by a negative. I just subtracted a 4. Now what am I going to do? Okay, you can do multiple things. You can multiply by the reciprocal if you know it. The reciprocal, remember, is the opposite of 2 over 3. Now if you forgot what that is, it's okay. All you got to do is do one thing at a time if you want. Notice that there's a division by 3. So let's multiply by 3 to both sides. Okay, that's going to get rid of that 3. So I'm left with 2n is greater than 6 times 3 gives me 18. Now what I can do is I now can divide by this 2. So n is greater than 9. That is my answer. Okay, now I wanted an interval notation. So I'm going to draw a number line. Here is 9. 9 is not included, and it's everything that's greater than that. Okay, so everything that's greater. Okay, so this is going to be from 9 all the way to infinity, parentheses. Okay, all right. So let's do part B now. So part B, what I usually do with all these fractions, if you tend to freak out with these fractions, it's fine. You're not alone. A lot of people do it. And one of the things that you want to do is I notice that there's a 3 here and I notice that there's a 2 here. And one of the things that you want to do is that you want to go ahead and get rid of these two different numbers. So how do you get rid of these two different numbers? Well, one way that to do it is to get the least common denominator. So the least common denominator of 3 and 2, or what number divides both into 3 and 2, in this case is 6. So what I'm going to do is I'm going to multiply every single thing by a 6. And that will hopefully get rid of that fraction. So I'm going to take this 6 and I'm going to distribute it. So what I'm going to have this negative 1/3 x. I'm going to have everything the same. Plus 1/2 greater than or equal to 4. And every single term is going to get a 6. So times 6 times 6 times 6. I'm going to put them over 1 so that I can put them as a fraction. Okay, so now what's going to happen? So what we're going to get is, so negative 1 times 6 is going to give me a negative 6 over 3x, plus this is going to give me a 6 over 2, and this is going to give me a 24. Now, negative 6 divided by 3 is going to give me negative 2x. 6 divided by 2 is going to give me a 3, and this is just going to be a 24. Okay, so nothing has changed. Notice that everything is exactly the same. All you want to do is just solve for x. Now, this is a really good trick, because what you want to do is you want to eliminate these this denominator. So always think of the number that divides into both of these, and the number that divides into 3 and 2 is going to be 6. Okay. I just multiplied across. Negative 1 times 6 gives me negative 6, and then 3 times 1 gave me 3. 1 times 6 is 6, 2 times 1 is 2, and then I divided negative 6 divided by 3 gave me negative 2, 6 divided by 2 gave me 3. Okay, so now I'm going to subtract by this 3, so I'm going to be left with negative 2x is greater than or equal to 24 minus 3 is going to give me 21. I'm going to divide by this negative 2. Oh, but I'm dividing by a negative. So what I'm going to do is I'm going to flip the sign. So this is going to be 21 over 2. Okay. And it's going to be negative. Okay. All right. Now notice, just leave it as a fraction. Don't put it as a decimal. Right now in this class, we don't want any decimals. Okay. So how am I going to write this in interval notation? Here is negative 21 over 2. Okay, negative 21 over 2 is included because there's an equal sign, and it's everything that's less than that. So it's all going to be all of this stuff. Here is negative infinity. So it's going to be from negative infinity all the way to negative 21 over 2, and then bracket. Okay. All right, and that's basically all there is to it, to solving these types of equations. So these problems can be really, really complicated if you don't switch the sign, because you might be doing things very, very wrongly, and you won't get the right answer. But that's basically all there is to these problems.